Okay, so I think we need to clear the air right at the start.
Mm-hmm.
When you say keto diet, most people, their mind goes to one place.
Oh, yeah. Butter and coffee?
Butter and coffee, gym culture, weight loss,
Yeah.
all of that. And, while our listeners are definitely savvy enough to see past the headlines, that lifestyle brand version has really taken over the last decade.
It absolutely has. It's a huge industry. But if you sort of strip all that away, the marketing, the
Yeah.
influencers, what's underneath is completely different.
Right.
I mean, the origin story for this diet has nothing to do with weight loss. It was designed for one reason: to save the human brain.
And that is exactly where we're going today. We're diving into a stack of research that positions keto not as a fad, but as a really sophisticated medical intervention.
Metabolic therapy.
Exactly. And the reason this all matters, the stake here, is that for a huge number of people with epilepsy, our modern drugs are failing.
That's the critical piece of context. I mean, we have amazing anti-seizure medications now, but even with all that, about 30% of people have what's called drug-resistant epilepsy.
Which is just a terrifying thought. 1 in 3 people.
Yeah.
You can have the best doctors, the best drugs, and the seizures they don't stop.
The medicine just hits a wall, and that is exactly where the ketogenic diet comes in, not as a choice, but as a prescription. In so many of these cases, changing the brain's fuel source can do what a pharmacy full of drugs cannot.
So our mission for this deep dive is to get into the how. How does this switch from carbs to fats actually calm a seizing brain? We'll look at the mechanism, the surprising link to gut bacteria.
Oh, that part is wild.
It's unbelievable. And then we'll get to the extreme cases, the Hail Mary in the ICU, where this is used to stop seizures that are otherwise unstoppable.
And we should probably start by saying, the science is new, but the idea is ancient.
Right. I saw that in the notes. Hippocrates, back in 400 BC, was prescribing fasting for seizures.
He was, and it worked. The ancient physicians knew that if you just stopped feeding someone, if you starved them, the seizures would often stop. The problem, of course, is...
You can't starve someone forever.
Right. It's not a great long-term treatment plan.
So the goal became, how do we mimic that state without the whole dying part?
Precisely. So you fast forward to 1921, Dr. Russell Wilder at the Mayo Clinic. He looks at this old data and asks this brilliant question. Can we trick the body chemically into thinking it's starving while still giving it enough calories to live?
And that's it. That's the birth of the ketogenic diet.
Yeah.
A biochemical fast.
That's the term he coined. He realized if you basically remove all the carbs and replace them with fat, you force the liver to switch gears. It stops using glucose and starts making these things called ketone bodies.
Acetoacetate and beta-hydroxybutyrate.
Yep. And those become the brain's new fuel.
Okay, so let's dig into that. Why does that swap matter so much? Is it just about keeping the lights on, or is there something different about the energy itself?
It's all about the quality of the energy. Think of glucose as a fast, hot-burning fuel. It's a bit volatile.
In fact, it produces a lot of exhaust.
Exactly. Oxidative stress. Ketones, on the other hand, are a much cleaner fuel. They're more efficient. So when brain cells switch to ketones, they actually produce more energy, more ATP, but with less metabolic waste.
So it stabilizes the whole system. If a seizure is an electrical storm, ketones are kind of raising the levees, making the brain less trigger happy.
That is a perfect way to put it. Just dampens all that excitability. But it's not only the fuel. The diet itself, it seems to change the actual neurotransmitters. We have to talk about GABA and glutamate.
The brain's brakes and its gas pedal.
The very same. Glutamate is the gas, tells neurons to fire. GABA is the brake, tells them to calm down. In epilepsy, that balance is off. Too much gas, not enough brake.
And the diet fixes the ratio.
It seems to. It promotes the creation of more GABA, so you're not just using a cleaner fuel, you're literally upgrading the brain's braking system. And there was another compound in the sources, egmatine. Did you see that?
I did, yeah. It's a neurotransmitter, but I wasn't totally clear on its role here.
It's so interesting. Egmatine acts like a neuroprotector, and studies show that on this diet, levels of it go way up, specifically in the hippocampus.
A vulnerable part of the brain for seizures.
Right. It's like the diet is posting extra security guards in the most important areas.
And speaking of the hippocampus, that connects back to the energy thing. The notes mentioned mitochondrial biogenesis. So we're not just using better fuel, we're building more power plants.
Yes. The diet actually signals the cells to make more mitochondria. This is so important because seizures use a massive amount of energy. If a neuron runs out of juice during that kind of stress, it can malfunction or even die.
So having more mitochondria gives you a bigger safety buffer.
A much bigger buffer. It makes the whole tissue more resilient.
Okay, so this all makes sense. Cleaner fuel, better brakes, more power plants. It's a solid case for what's happening inside the skull. But then the research took a turn that I did not see coming. The gut.
The gut-brain axis, yeah.
I mean, this feels like a huge pivot. We're talking neurology, and now we're talking about bacteria in your colon. The Olson study you shared, it seemed to suggest the diet might not even work without them.
This is where things get really, really interesting. So in that study, they put mice on a keto diet, and yep, seizures stopped. But they saw the diet totally changed the mice's gut microbiome.
It boosted a couple of specific bacteria, right?
Two in particular just exploded: Akkermansia, Misonifila, and Parabacteroids. But here's the crazy part. They then gave those seizure-free keto mice a strong course of antibiotics.
Let me guess. The seizure protection went away.
It vanished completely. The mice were still on the diet. They still had ketones in their blood. But because the bacteria were gone, the protection was gone.
That's profound. It means the ketones themselves aren't the full story.
Not at all. The bacteria are a critical part of the mechanism.
So wait, what does that mean for a person? If a kid is on this diet for epilepsy and they get an ear infection, they take amoxicillin. Could that trigger a relapse?
That is the million-dollar question right now. It seems these specific bacteria produce chemicals that travel from the gut to the brain, and those chemicals are what help regulate the GABA and glutamate balance. So you kill the messenger.
The message never arrives. Wow. It just shatters that old idea of the brain being this isolated castle, you know?
It's in a constant conversation with the gut. And this opens up some really wild ideas for the future. But first, I want to take this whole mechanism, fuel, brakes, bacteria, and look at where it gets pushed to its absolute limit.
The ICU.
The ICU. We need to talk about super-refractory status epilepticus.
SRSE. Yeah, the definition alone is a nightmare.
It is. So status epilepticus is a seizure that won't stop. You rush to the ER. They give you heavy drugs. It usually breaks. Super-refractory means they've put the patient in a coma on general anesthesia, and the seizures are still happening.
So a patient is unconscious, on a ventilator, their brain is just continuously seizing, and the doctors have thrown everything at it, and nothing works.
Nothing. The mortality rate is between 30 and 50%. And these are often young people who maybe had an infection, like with virus syndrome, and they are dying.
So how do you even start a ketogenic diet in that situation? A patient in a coma can't eat.
It's a medical formula. It's essentially liquid fat, cream, and oils delivered through a feeding tube right into the stomach. It's not food, it's life support.
And the results, I was looking at the Tucker study on adults in this state.
The Tucker study is incredible. 10 adults. The median time they had been seizing before the diet was 21.5 days.
3 weeks of nonstop seizures. I can't even imagine.
You'd assume the damage is catastrophic. But they started the keto diet through the tube, and 9 out of the 10 patients, their seizures stopped. And it was fast, a median of 3 days.
3 weeks of failure with drugs and 3 days of fat stops it.
It just tells you this is a metabolic problem at its core, not just an electrical one. There was another study, the Park study, mostly on kids with that fire syndrome. They saw a 56% rate of complete seizure freedom.
Which let them get the kids off the ventilators.
Exactly. Getting them off the ventilator is everything. It's just amazing that changing a macronutrient can do what propofol couldn't.
It is.
Yeah.
But we should be clear. In the ICU, it's a procedure. For someone trying to live their life on this diet, it's incredibly difficult.
Oh, it's a huge burden. Let's bring it back to that daily life. The classic ketogenic diet isn't just low carb. It is brutally rigid.
It's the 4-to-1 ratio, right?
Right. 4 grams of fat for every 1 gram of protein and carbs combined. Everything is weighed on a digital scale. One wrong bite, a single cookie, could be enough to trigger a seizure.
That sounds so isolating, especially for a teenager. No birthday cake, no pizza with friends.
The social isolation is a huge issue. And then there are the side effects. Constipation is common. Kidney stones can happen, that initial keto flu. It's tough, which is why researchers have been looking for easier versions.
And that's where the modified Atkins diet or a MAD comes in.
Yes, the MAD is a game changer for so many families. The ratio is closer to 1-to-1. You still limit carbs, maybe 10 or 20 grams a day. But protein isn't restricted, and you don't have to weigh the fat, you just have to encourage it.
That sounds so much more doable. Is it as effective?
For a lot of people, yeah. Surprisingly, for many adolescents and adults, it gives nearly the same level of seizure control as the classic version. It still produces enough ketones to do the job.
And there was one more, the low glycemic index treatment.
LGIT, yep. That one is less about the amount of carbs and more about the type of carbs. You only eat foods that release sugar very slowly. It's a gentler approach, but for some people, it's enough.
I want to go back to something for a second. We talked about this diet being a last resort. But for some people, like those with GLUT1 deficiency, it's the only resort. Can you explain that? It seems like a perfect example of personalized medicine.
Oh, it is the absolute home run example. GLUT1 is a genetic disorder. So think of GLUT1 as the only door that lets glucose into the brain. In these kids, that door is broken. So their blood can be full of sugar, but their brain is literally starving to death.
Starvation in the land of plenty.
Exactly. And no anti-seizure drug can fix a fuel problem. But here's the beautiful part. Ketones don't use that door.
They have a different way in.
They have their own private entrance. So when you put a child with GLUT1 on a keto diet, you are completely bypassing the broken door and delivering fuel right where it needs to go. The seizures stop, the movement disorders improve. It's as close to a cure for the symptoms as you can get.
So in that specific case, this isn't alternative medicine. This is the medicine.
It is the primary first-line therapy, and I think that really gets to the heart of this whole deep dive. We have this tendency to think of drugs as science and diet as, wellness fluff.
This research just completely shatters that idea. It proves that food is pharmacology.
It really is. When you change your diet this drastically, you're changing hormones, neurotransmitters, your cell's power grid, and the bacteria living inside you. You're pulling levers that some drugs can't even touch.
So looking ahead, where does this all go? You mentioned the gut bacteria, the Akkermansia. If we know they're doing a lot of the work, could we just skip the diet?
That is the big provocative thought, isn't it? This idea of psychobiotics.
A probiotic for your brain.
Essentially, if we can figure out exactly what chemicals those bacteria are making that stop the seizures, can we just put that in a pill? Can we give someone a targeted probiotic that gives them all the brain benefits of keto without them having to give up birthday cake?
That would be the holy grail. All the protection, none of the restriction.
It's being very actively researched. We're not there yet, but the fact that we're even asking that question shows how far we've come.
It's an incredible story. From an ancient observation about fasting to a sophisticated metabolic therapy, and now maybe to a future of bacterial medicine, it really makes you rethink what brain food actually means.
It certainly does. The most powerful pharmacy might just be the one that's already inside us.
Well, that is a lot to chew on. Pun definitely intended. Thank you for taking us through all this.
My pleasure.
And thank you to everyone listening. We will see you on the next deep dive. Stay curious.